You're holding something small, but it survived fire hot enough to liquefy steel and pressure strong enough to crush a car. Every coin in your pocket began as an industrial brute, forged, burned, slammed, and tested before it ever reached your hand. And strangely enough, some of them cost more to make than what they're actually worth. It all begins with massive coils of metal, each one stretching nearly 1,500 feet long, about the length of 4 football fields laid end to end. These coils arrive at the mint in towering stacks, their color hinting at the alloy inside. Copper-plated zinc for pennies, copper-nickel blends for dimes and quarters, each formula precisely engineered for durability, conductivity, and resistance to corrosion. A robotic lift hoists a coil from storage and mounts it onto a heavy-duty uncoiler. The turbine begins to rotate slowly, feeding the thick metal strip forward like a steel ribbon. The sheet moves toward a high-speed blanking press. A technician stands nearby, not to do the heavy lifting, but to make fine adjustments. The metal can be stubborn, and even in an automated world, experience still matters. Then the press comes alive. With a thunderous rhythm, it punches perfect circular discs from the sheet, like a giant industrial cookie cutter, up to 14,000 blanks every single minute. The sound becomes a metallic heartbeat echoing across the factory floor. Buckets below fill rapidly with smooth, unfinished discs, but on the other side of the press, twisted skeletal remains of the sheet, called webbing, pile up in jagged heaps. That scrap metal will be shredded and recycled back into the system. The discs, known as blanks, are not finished coins yet. They have the right thickness, but their gauges are sharp and flat. Before they can take shape, they must endure one of the harshest stages of their journey, annealing. The blanks travel through a long industrial furnace, where temperatures soar to nearly 1,600 degrees Fahrenheit. Inside, oxygen is carefully removed to prevent oxidation. Flames dance in controlled patterns as the metal softens without tarnishing. When they emerge glowing red hot, they look untouched, but internally their structure has changed. They are now soft enough to be stamped without cracking. But heat alone isn't enough. The coins immediately plunge into a quenching bath, a chemical solution far more complex than ordinary water. Citric acid removes surface oxides and restores brightness. Lubricants prevent the blanks from sticking together as they cool. The reaction is controlled, precise. Without it, the metal would dull, discolor, or fuse into clumps. From there, they are lifted out, sometimes by massive scoop baskets, sometimes by rotating drum systems depending on the facility. They enter washing tunnels where detergents and anti-tarnish agents scrub away any residue. Then hot air dryers blast them clean. Now comes the transformation that gives coins their distinctive edge. The blanks pass through an upsetting mill, a circular groove slightly narrower than their diameter. As each blank rolls through, the pressure forces metal upward around the edge, forming a raised rim. This rim is critical. Without it, the coin would flatten uncontrollably during striking. It also helps prevent wear once in circulation. At this stage, the discs are called planchettes. They're inspected carefully. Precision gauges measure diameter and thickness. Optical systems scan for defects. Counterfeiting attempts grow more sophisticated every year, so exact specifications are non-negotiable. If approved, the planchettes move forward to the striking presses, the most dramatic moment of their creation. Each planchette slides into a hardened steel collar. Above and below it sit engraved dies, one for the front design, one for the back. In a fraction of a second, the press slams shut with forces ranging from 35 to over 100 metric tons depending on the denomination. The metal flows outward, filling every microscopic detail of the die, from a president's hairline to the ridges of an eagle's wing. Some collectible coins are struck twice. Some massive silver pieces endure over 500 metric tons of pressure. But even standard coins are produced at astonishing speed, hundreds per minute per press. Multiply that across dozens of machines, and tens of thousands of coins are born every single minute. When the dies lift, the transformation is complete. The once blank disc now carries identity, value, and national symbolism. Finished coins spill on conveyor belts in shimmering cascades. Inspectors monitor the stream constantly. If a defect appears, misalignment, double strike, incomplete design, that batch is pulled. Faulty coins are sent to a machine known informally as the waffler. It bends them into a crisscross pattern, permanently destroying their form before they're recycled. The coins that pass inspection continue forward. They are counted automatically, weighed to exact totals, and funneled into enormous canvas bags. Each bag can weigh thousands of pounds. Forklifts lift them carefully and stack them high in secure vault-like storage areas. There they wait, sometimes for weeks, until the Federal Reserve places an order. And eventually, one of those coins finds its way into your change tray, your glove compartment, or your pocket. A small piece of metal, forged in fire, shaped by tons of pressure, inspected against counterfeiting, manufactured by the thousands every minute. It may seem ordinary, but behind every coin is an industrial story most people will never see.